It's strange how a story that begins with a quiet countdown on a Florida morning can end up rewriting humanity's place in the universe. Back in the late summer of 1977, nobody standing near those two rockets truly understood what was leaving Earth. They saw the flames, the shaking towers, the long trails of fire disappearing into the sky. But they didn't know they were watching the beginning of the longest continuous experiment in the history of our species, an experiment still running today. More than 45 years later, two spacecraft, nearly twins, launched just weeks apart. Voyager 2 went first, breaking free of Earth in late August, and Voyager 1 followed in early September. What nobody expected was that the second launch would become the first arrival. Voyager 1 took a sharper, more direct path toward Jupiter, one that stole a bit more speed from the giant planet's gravity. By the time both crafts were racing through the outer solar system, Voyager 1 had already overtaken its sibling and earned the name Number 1 in more than just title. Those early months were a quiet stretch of deep space flight, a calm before the storm of discoveries waiting at Jupiter. Engineers watched the data come in, line after line of numbers, tiny whispers of telemetry carried across hundreds of millions of miles. Nothing dramatic, no surprises, just two machines settling into their roles as explorers, accelerating into the cold dark, like arrows fired from a planet that was beginning to understand the size of the universe around it. And then the encounters began. Jupiter wasn't just another destination, it was a gateway. A massive gatekeeper that could either slow a spacecraft to death or fling it outward with unimaginable velocity. Both Voyagers used that gravitational slingshot, but they used it for different destinies. Voyager 1 curved sharply after Jupiter, preparing for a close encounter with Saturn and its moon Titan, a world so mysterious at the time that NASA was willing to sacrifice the craft's future just to get a closer look. Voyager 2 took the long road, a path built for endurance rather than speed. After Jupiter and Saturn, it would continue on to the two most remote giants in the solar system, Uranus and Neptune. It would become the only machine humanity has ever sent to those worlds. By the time both spacecraft completed their planetary grand tour, they had already changed science forever, revealing volcanic moons, fractured rings, impossible storms, and landscapes nobody had imagined. But their real story was only beginning. The moment the last planet slipped behind them, the Voyagers officially entered their second mission, leaving the solar system. That phrase sounds simple. It isn't. Because the question hiding underneath it, what counts as the edge of the solar system, turns out to be one of the trickiest questions in all of astronomy. Some scientists define the boundary as the Heliopause, the invisible shield where the solar wind loses its strength and interstellar space begins to take over. Others argue that the true edge is much farther, at the distant reaches of the Oort Cloud, a frozen sphere so huge that it might take tens of thousands of years to cross. But while humans debated the definition, the Voyagers kept moving. Voyager 1 was the first to punch through the Heliopause. In 2012, Voyager 2 followed 7 years later. In 2019, they became the only two objects built by human hands to fully enter the space between the stars. And even though the Oort Cloud still lies far beyond them, so far that it'll take millennia to reach, they have already left the protective bubble carved out by our sun out there. In the raw interstellar medium, the rules change. The environment shifts, radiation increases, and every signal that tries to make its way home gets a little weaker each year. Still, for decades, they kept talking to us. Weak signals, yes, but steady, like an old friend whispering across impossible distance. Their nuclear power supplies faded gradually, forcing engineers to shut down instruments one by one, turning off heaters, cameras, detectors. But the crafts continued on, stubborn and patient, carrying the golden records on their sides like messages sealed in bottles drifting through a cosmic ocean. No one expected the quiet to break. But then, suddenly, it did. A few months ago, the streams of data coming from Voyager 1 began to distort, not disappear, just fade, as if something subtle had shifted. Engineers checked everything: the transmitter, the power levels, the onboard computers, all seemed fine. And yet, the signal kept weakening, as though the spacecraft was slowly turning its face away from Earth. That's when suspicion fell on one system, the Attitude and Control Subsystem, or ACSA Guidance System, responsible for one job: keeping the high-gain antenna pointed with microscopic precision at a planet now more than 24 billion kilometers away. Any tiny misalignment, even a fraction of a degree, would cause Earth to drift out of sight. And in the void between stars, there's no backup, no repair crew, no margin for error, and the point and aim is lost. The spacecraft becomes a ghost, still moving, still functioning in a sense, but unreachable forever. Scientists believe the intense radiation of interstellar space may have slowly degraded some of the components, nudging the antenna just slightly off target. It's a small shift, but over these distances, small is catastrophic. The result is a slow fading, like a flashlight beam drifting away from someone standing across a desert at night. You can still see it, until you can't. Now, engineers are trying everything: commands, resets, clever reroutes, to bring that alignment back. But the possibility looms that the signal won't recover, that Voyager 1 may fall fully silent before the middle of this decade. And if it does, its journey won't end. It will just continue without us, slipping away into the dark on a path that will eventually take it closer to another star than to our own. A tiny machine, no bigger than a compact car, carrying humanity's voice, moving on through the galaxy long after our ears can no longer hear it. For most people, the story of the Voyagers feels like ancient history, something sealed inside textbooks or documentaries replayed late at night. But for the engineers who still sit in front of their consoles in California, it's not history. It's ongoing, a living thread stretched across 4.5 decades, fragile yet unbroken. And every time a weak pulse from Voyager 1 or Voyager 2 arrives at Earth, it feels like proof that this impossible thread still holds. In the early years after the planetary encounters, the Voyagers entered a kind of quiet maturity. There were no more dramatic flybys or postcard pictures of alien worlds. Their cameras went dark. Their missions shifted from exploration to endurance. What mattered now wasn't what they could see, but what they could sense. Magnetic fields, charged particles, cosmic rays, the faint textures of a region of space humanity had never touched before. They became floating laboratories, running experiments in a part of the universe where no spacecraft had ever traveled. And this region, this strange borderline between the solar wind and the interstellar medium, turned out to be far more complex than anyone predicted. The solar wind doesn't simply fade. It battles against the pressure of our galaxy, a constant struggle of particles, a cosmic tug-of-war, occurring in an invisible frontier. And the Voyagers drifted straight into the middle of that battle. Even back then, there was debate, real scientific disagreement, about what it meant to leave the solar system. Some argued that since the Sun's gravity extends unimaginably far, neither Voyager could be considered outside the solar system until they passed beyond the Oort Cloud. Others insisted that the Heliopause is the true border, because beyond that point, the sun's influence becomes a whisper, lost in the roar of the galaxy. But the Voyagers weren't here to settle that debate. They were here to measure, to observe, to send home data that could outlive every assumption humans had made about our cosmic neighborhood. And the data, it changed everything. Voyager 1 recorded sudden drops in solar particles, followed by spikes of galactic radiation, clear signs it had crossed out of the sun's protective bubble. Voyager 2 confirmed the same patterns years later. Humanity had, through these silent machines, reached interstellar space for the first time. There were no fireworks, no dramatic images, just numbers, beautiful, quiet numbers that rewrote our cosmic map. But traveling so far comes with a cost. Space is not empty. It's harsh. It's filled with radiation sharp enough to slice through silicon, cold enough to freeze metal, quiet enough that even the smallest problem can remain hidden for years before revealing itself. And as the Voyagers pushed farther into that darkness, their nuclear generators slowly aged. The power output decreased year after year, making everything harder. Engineers faced decisions that felt like gut punches. Which instrument do we turn off next? Which heater do we sacrifice? How much scientific vision do we trade for survival? Voyager 2 lost its first instruments early, then its heaters, then more sensors, shrinking from a full suite of scientific tools to just a handful. Voyager 1 followed the same path. They were like marathon runners shedding weight to keep going, piece by piece, until only the essentials remained. And yet, the remarkable part is that even with just a few instruments alive, magnetometers, particle sensors, these spacecraft still delivered discoveries powerful enough to reshape theories about interstellar space. But beneath the scientific triumphs lay a quieter tension. They were aging. Every circuit, every transistor, every mechanical part had been built in the early 1970s. Most of the people who designed them had retired or passed away. The team today is made of engineers who inherited a machine older than themselves, a machine they can't touch, a machine they can only talk to through faint signals that take more than 20 hours to cross the void. That distance is not just physical, it's emotional. When something goes wrong with a modern spacecraft, you troubleshoot quickly. When something goes wrong with Voyager, the delay alone turns every problem into a test of patience and hope. You send a command, wait nearly a day, and pray that the craft still has the strength and the alignment to whisper back. And in recent years, those whispers have grown weaker, not just because of power decline, but because the crafts are moving deeper into a region where interstellar particles slam into them from every direction. It's like sailing into rougher cosmic seas. The structure still holds, but the stress accumulates. You don't see the damage until it becomes obvious, and by then, it's usually too late. That's why the latest issue with Voyager 1 hit so hard. When the signals began to degrade, it wasn't just a technical glitch. It felt like the first clear sign that the spacecraft was struggling in a way that couldn't be fixed with clever coding. The antenna's alignment appeared to drift, subtly, almost imperceptibly at first, but imperceptible shifts, when amplified over billions of miles, become catastrophic. And suddenly, the most distant machine ever built by human hands was no longer pointing directly at us. The team tried everything: resets, reroutes, diagnostic commands. They scoured telemetry, hunting for clues buried in corrupted bits. They debated possibilities. Was it radiation? A stuck actuator? A failed sensor? Each answer came with the same fear. If the antenna moves just a little more, the Earth will slip out of view entirely. And if that happens, the spacecraft becomes unreachable forever. This fear isn't dramatic. It's realistic. Everyone knows the clock is ticking on both Voyagers. Their power will eventually run out. Their instruments will go dark, their voices will fade, but nobody expected the silence to arrive like this. Sudden, uncertain, slipping through the cracks of a system that had held strong far longer than anyone predicted. But even now, even with the risk looming, there's something unshakable in the way people talk about these spacecraft. They don't describe them as machines. They describe them as partners, small, resilient companions that carried our curiosity farther than anything else in history. Companions that trusted us enough to follow commands sent across half a light day of emptiness, and maybe that's why the possibility of losing Voyager 1 feels so heavy. It's not just about losing data. It's about losing the last connection to a moment in human history when we dared to launch something into the unknown with nothing but hope and math holding it together. Something built by people who believed the future would still care. Decades have passed. Generations have changed. But Voyager 1 is still out there, still moving, still holding the golden record, a message to anyone or anything that might one day find it. A message saying who we were, what we valued, what we sounded like. A fragile, golden memory of Earth drifting through a galaxy that has never heard of us, and as its signal flickers, as its antenna struggles to keep its aim, we're reminded of the truth at the heart of the Voyager mission. It was never about reaching a destination. It was about proving that humanity could sense something beyond every border we ever knew, and trust it to keep going long after we could no longer guide it out. In the interstellar dark, where sunlight is nothing more than a distant memory, and cosmic rays slash through space like invisible storms, the Voyagers continued their lonely journey. Nothing around them changes quickly. There are no landscapes, no shadows, no sense of direction. Just a constant drift through a place where even time feels slower. And yet, despite the emptiness, the spacecraft kept uncovering clues. Subtle patterns in radiation, magnetic irregularities, pressure waves moving through interstellar gas. Information that helped scientists sketch a rough picture of the frontier between our solar system and the rest of the galaxy. What surprised everyone was how dynamic that frontier turned out to be. The heliosphere, once imagined as a neat bubble, isn't smooth at all. It's dented, stretched, rippled, shaped by the sun's own motion through the Milky Way, by interstellar winds, by magnetic turbulence far beyond anything humans could imagine. The Voyagers weren't just drifting through a boundary. They were navigating a changing, unstable terrain, a terrain made not of matter, but of fields and forces. Every piece of data they sent back became a revelation. Scientists learned that interstellar plasma behaves differently than predicted. They found hints of pressure regions, strange gradients in particle energy, signs that the space between stars isn't a void at all, but a restless sea. And each discovery made the fragile survival of the Voyagers even more remarkable. These weren't modern machines with redundant systems and hardened processors. They were relics of the 1970s, built with memory measured in kilobytes, processors slower than the cheapest modern calculator, and hardware that hadn't been touched by human hands in nearly half a century. As the years went on, a strange duality formed. On Earth, the images of Jupiter and Saturn that once dazzled the world faded into the background. Space exploration moved on. Newspapers stopped talking about the Voyagers. Kids grew up without ever hearing their names. Missions like Cassini, New Horizons, Curiosity stole the spotlight. And yet, in a quiet control room in California, a tiny team continued to watch over these distant wanderers, refusing, even now, to let them slip away unnoticed. These engineers inherited a kind of cosmic responsibility. They didn't design the Voyagers, but they understood them intimately. They knew the quirks, the temperaments, the strange behaviors caused by aging circuits and cold metal. They learned to treat the spacecraft like elderly explorers, still capable, but in need of gentle handling. Commands had to be carefully crafted, power budgets recalculated, instruments prioritized with painful precision. Every decision carried consequences. Turn off the wrong heater, and you might lose an entire system forever. Redirect power incorrectly, and a critical instrument might drain away what little life remained. This delicate dance became a rhythm. Listen to the faint signal. Interpret the data. Plan the next step. Over and over, year after year. It didn't matter that the spacecraft were billions of miles away. To the team, they felt close. Like old friends calling home less and less frequently, but still calling. And then came the moment that shifted everything. The team noticed the Voyager 1 signal wasn't behaving normally. It wasn't gone. Not yet. But it wasn't right either. Bits were missing. Data packets arrived corrupted the carrier tone. One steady, wavered just slightly, like a person losing their breath mid-sentence. It wasn't dramatic enough to be obvious, it was subtle. Subtle enough to terrify the people who understood exactly what it meant. They suspected a pointing error. The antenna, the spacecraft's single lifeline to Earth, wasn't perfectly locked onto our planet anymore. And that should have been impossible. The craft's attitude control system was designed to keep the high-gain antenna aligned with extraordinary precision. Even tiny deviations, fractions of a degree, were supposed to be corrected automatically by thrusters that fired in controlled bursts. So why wasn't Voyager correcting itself? Engineers pored over telemetry, trying to decode the spacecraft's behavior, like archaeologists studying fragments of a lost language. Radiation damage? Faulty sensors? A stuck gyroscope? A corrupted memory block? There was no single clear answer, only guesses. And every hour that passed increased the risk. If the antenna drifted even a little more, communication could drop to zero. Once that happened, there would be no way to send commands, no way to reorient the craft, no way to bring it back. This wasn't like losing a rover on Mars or a satellite in Earth orbit. There was no rescue plan, no second chance. If the signal died, Voyager 1 would remain forever silent. The team sent a series of commands, resets, reboots, gentle nudges to the attitude system. And then they waited 22 hours for the signals to arrive. Another 22 hours for any response. Nearly 2 days to find out if a single instruction had worked. Time moved differently when you were dealing with a machine so far away that light itself crawled to reach it. Some commands seemed to help, others changed nothing. A few made the data even stranger. But the signals still came. Thin and fragile, like a bird singing from the edge of hearing. And with each whisper, engineers felt a mixture of relief and dread. Relief that Voyager 1 was still alive. Dread that they might be witnessing the slow unraveling of the longest-running mission in human history. And yet, through all of this, there was no panic, just steady, quiet determination. Because the Voyagers were more than spacecraft. They were symbols, symbols of what humans can accomplish when curiosity outweighs fear. When a generation decides to launch something not for power or territory, but simply to know more. This mindset shaped how the team responded. They didn't speak about saving Voyager. They spoke about shepherding it, protecting it, giving it the best possible chance to continue, even if only for a little longer. If the spacecraft was going to fade, it would fade with dignity. Still doing science, still sending home whatever it could, still carrying the golden record into the deep unknown. And while Voyager 1 struggled, Voyager 2 continued its quieter journey. Its instruments were aging too, its power waning year by year, but it remained stable. Its antenna still pointed perfectly at Earth engineers joked, half lovingly, that Voyager 2 had always been the calmer of the two siblings, slower, more patient, taking the scenic route through the solar system. And now, older and wiser, it seemed to be handling interstellar space with a bit more grace. But even Voyager 2 wasn't immune. Its power was dropping. Instruments were shutting down. Thrusters showed signs of wear. And everyone knew that sooner or later, it would face the same kinds of struggles as its twin. The truth was simple, yet hard to accept. The Voyagers were reaching the end, not because they failed, but because they succeeded so far beyond anything expected of them that time itself finally caught up. But endings in space are different. They don't happen all at once. They happen slowly, signal by signal, system by system, year by year. And as long as there was even a faint whisper from Voyager 1, the team refused to treat it as a goodbye. Because the story wasn't just about the spacecraft surviving. It was about what it meant for humanity to create something that could travel so far, for so long, and still reach back across the dark to say, "I'm here." There's a moment, somewhere beyond the comforting warmth of the sun, where distance stops feeling like a number and starts feeling like a destiny. Voyager 1 crossed that threshold years ago. So far from home that Earth is just a pale, invisible point lost inside a beam of radio waves, scarcely strong enough to touch us. And now, as its voice flickers and its antenna struggles to hold aim, we find ourselves confronting a truth we always knew was coming but never wanted to face. The moment when the most distant object ever created by human hands must finally go on without us back on Earth. The control room lights glow softly in the early hours of the morning. Most of the world sleeps, unaware that engineers are watching a faint signal older than many of the people monitoring it. The frequency drifts. The patterns wobble. Sometimes entire packets of information collapse into static. But even then, the team leans closer, determined to squeeze meaning out of every photon the spacecraft sends home. There's something deeply human about this act. Leaning in to hear someone who's whispering. Refusing to give up even when their voice begins to fail. The situation has grown more complicated. The recent efforts to correct the antenna drift produced mixed results. Some diagnostics came back intact. Others were scrambled. The spacecraft responds, but not consistently, as if pieces of its memory are slipping just out of reach. That's the cruelty of cosmic radiation. It doesn't destroy in one dramatic moment. It erases slowly, unpredictably, one corrupted bit at a time. And a machine designed in the 1970s has no shield against such erosion. Still, the team persists. They develop new commands, new workarounds, new ways of speaking to a spacecraft whose mind is fading. They strip down systems to their most essential behaviors. They reroute signals. They construct sequences so elegant and minimal that they feel like poetry written in binary. Because when you're talking to something 24 billion kilometers away, simplicity is a kind of love. At the same time, the inevitable discussions begin. Quietly, carefully. What happens when the signal is lost completely? What happens when the spacecraft no longer answers? The team doesn't talk of failure. Instead, they talk about transition. About the moment when Voyager stops being an active mission and becomes a silent traveler. A messenger drifting through the galaxy with no one left to hear its voice. Not an ending, just a change of state. And while engineers wrestle with the fading signal, scientists reflect on what the Voyagers have already given us: the images of Jupiter's storms, the volcanic fountains of Io, the braided rings of Saturn, the frozen oceans of Europa, the first close-ups of Uranus and Neptune, worlds we've never seen again since Voyager 2 passed them. In the 1980s, entire fields of planetary science were born from the data these spacecraft sent home. Entire generations of researchers owe their careers to discoveries made by a probe, launched before their parents even met. But maybe the greatest legacy of the Voyagers isn't scientific at all. It's philosophical. There's something humbling about knowing that two small machines, built with the technology of another era, running on power supplies older than most nations, became the first ambassadors of Earth to interstellar space. They carried the golden records, greetings, music, images, instructions, a portrait of humanity preserved at a moment when the world was young enough to believe its future could reach the stars. And even if no one ever finds them, even if they drift in silence for a billion years, the gesture itself feels meaningful. It says, we tried, we cared, we wanted someone, somewhere, someday, to know we existed. Voyager 1 will one day lose its alignment completely. Maybe soon, maybe in a year, maybe a little longer. Eventually, its antenna will drift beyond the narrow cone through which Earth's receivers can listen. When that happens, the spacecraft won't shut down. It won't break apart. It will simply keep going. Its systems running until the last watt of nuclear power fades. Its instruments freezing one after another. Its memory growing quiet. And long after it falls silent, it will remain in motion. It will sail through the interstellar medium, through regions no human mind has ever pictured. In 40,000 years, it will pass near another star, Gliese 445, closer to it than to our Sun. Humanity will be different then. If we still exist at all, civilizations may rise and fall. Oceans may shift. Languages may disappear. But Voyager will still be moving, still carrying the golden record, still representing a species it can no longer talk to. That's the part that catches people off guard. The idea that a machine we build will outlast us by tens of thousands, maybe millions, of years, that our first true interstellar traveler isn't a starship, but a metal artifact the size of a small automobile, launched by people who just wanted to see what was out there. Voyager 2 will follow the same path one day. Its signal is stable now, but its power is dwindling. By the end of this decade, its last instruments will go dark. Eventually, even its transmitter will fall silent, and then it too will drift into the long night, joining its twin on a path that winds deeper and deeper into the galaxy. The silence that follows won't be tragic. It will be earned. Because the Voyagers were never meant to return. They were meant to continue, to keep pushing outward, past fear, past limitation, past even our ability to hear them. They embody a courage unique to exploration, the courage to move forward even when forward leads into darkness. And on Earth, long after the faint signals have stopped arriving, their story will remain in textbooks, in documentaries, in the memories of those who watched them launch. Children not yet born will grow up hearing about the two little spacecraft that refused to stop. Spacecraft that carried our voice farther than any shout we ever made into the sky. Maybe someday, when humanity finally builds ships capable of reaching the stars, our explorers will cross paths with the Voyagers, finding them drifting quietly, still carrying their golden message, and maybe they'll pause for a moment just to look at them, the same way travelers look at monuments built by those who came before. A reminder that even in the earliest days of spaceflight, we were already dreaming big, already reaching, already leaving footprints in the cosmic sand. Until then, Voyager 1 and Voyager 2 continue onward, beyond the sun's reach, beyond the maps, beyond everything familiar. They are, quite literally, the farthest extensions of humanity. Our hands stretched into the dark, our curiosity given form and momentum. And somewhere, in that endless silence, two small machines sail on, alone, unstoppable, eternal by comparison to the brief creatures who made them, still carrying our message, still representing our hope, still proving that even the smallest act of exploration can echo across the universe long after the explorers themselves are gone.